Andre DeWall will be discussing and presenting on SAS visual analytics. Andre has a PhD in theoretical computer science from the University of Bristol. He was an associate professor at Northwest University in South Africa, where he was the founding one of the founding members of the Center for Business Mathematics and Informatics. He has done research on data mining, predictive modeling, and he is the co-developer of the AutoGAN modeling node in SAS Enterprise Miner. He's also published a number of papers on data mining and neural networks. He is joining us from the SAS Institute in Cary, North Carolina, where he is an analyst with their global academic program. Please join me in welcoming Andre DeWall.
Thanks very much and welcome to this session. So I know I'm the only thing standing between you and your lunch, so I'll try and make it as interesting as possible. We always say that with the heavy hors d'oeuvres that we've been promised, you can judge the success of a university or a company by the size of the prawns that are being served. So we'll see what happens at one. So thanks for staying with me, and I was asked to give you a demo of SAS Visual Analytics. So when I heard about SAS Visual Analytics, I thought, okay, isn't a pie chart a pie chart? Why will companies pay $40,000, $50,000, $60,000 for souped up pie charts? Isn't kind of, what can you do with a pie chart to make it more interesting? But I was very wrong. It's not only pretty pictures, it's then adding advanced analytics on top of your visualizations to really see what is happening with your data. So I have a couple of slides, and then I'll move on to demonstrating visual analytics. So hopefully a couple of things you've heard this morning will resonate with what I'm showing and what I would like to tell you. So first of all, let's talk about the Internet of Things. Then we've heard about big data, how much data is being generated, and then a last quote about interactive analysis and where visualizing data comes in. So we've heard about oil and gas industry this morning and these oil platforms and monitoring the flow of oil and gas and their operations so that they can do preventive maintenance and so they can prevent oil spills and other disasters, also save millions of dollars in lost production. So these oil platforms generate a huge amount of data, and SAS can analyze this data in real time or otherwise once it's stored, analyze to see what happens with your data. Jerry will like this example. So I've got a small little car there in North Carolina, and once a month I get a report for my car that tells me how it is doing and what the health of my car is. So it tells me about the powertrain and the engine and the fluids and so on. But the interesting thing is it also even knows the amount of air in the tires of my vehicle, so 40 PSI. So coming back to the insurance industry, I can think of a worst case scenario for me. This car's got a 0 to 60 timer. And now and then I exercise this timer kind of in a built-up area, 45 mile an hour area. And if Chrysler knows this information, there's just a short step in sharing this information with my insurance company. So my insurance company might then say, okay, this guy from North Carolina is not as safe a driver as he portrays to be, so let's hike up his insurance rates because he exercised the 0 to 60 timer in his vehicle. So big data is here. Companies are going to share data with each other, and we have to be prepared for that. The last example that I really like is the Boeing 787. And I was lucky enough to be at JSM in Seattle last week to be able to visit the Boeing plant and to really see the Boeing 787 being built right in front of your eyes. So this thing is basically a flying computer. It generates 20 terabytes of data each hour. And I think Boeing said that they're going to build at least 100 of these planes this year. So multiply that by the time they are on the air and the data being generated, and it's just huge amounts of data. And Boeing going to use it for various purposes, but also for preventative maintenance to try and predict when something is going to fail and not having to take the plane out of the air and do maintenance on the ground. My last slide, visualization has become so important that it's now basically a subject by itself. A couple of weeks ago in Cary in North Carolina at SAS, we had an academic summit where we had approximately 80 professors from all over the world discussing advanced business analytics curriculums and also data scientist curriculums and what is needed, what the universities need to produce. So we had people from Australia, New Zealand, Canada, Europe, South Africa, and so on. It was a very productive 2 weeks. And during the discussion of the curriculums, basically everybody said that visualization has now matured to the stage where it is a topic to be taught by itself. Previously, it was just a kind of maybe a 1 hour or a short part of a course. But now visualization is being taught as a separate course because it is so important. Also, if you have 1 billion records in your data, 1 billion observations, you can't really scroll through your data anymore to try and find errors and outliers and patterns. So you have to do something else. And one way of understanding your data is to visualize your data. So here's a quote from the KDD Nuggets newsletter. It says, "Interactive analysis is the best way to really figure out what is going on in a data set. If you want to understand a data set, you have to be able to play around with it and explore it. You need to make tables, make plots, identify quirks, outliers, missing data patterns, and problems with the data. To do this, you need to interact with the data quickly." So SAS Visual Analytics is a tool then that was designed to allow you to do this. So it doesn't matter what the size of your data set is. It could be 1 billion records, could be a couple of thousand variables. You should get with the right, obviously the right hardware, Hadoop cluster with a certain number of processors and so on, and memory in the background. You should be able to get similar response on the visualizations that I'm getting on a couple of thousand or million records on a couple of billion records. So that's my introduction. So let's fire up SAS Visual Analytics. And there we are. So SAS Visual Analytics is a tool for everybody in the organization. We heard the word democratization. And a favorite story I like to tell is a couple of months ago, I was flying on a Delta jet somewhere, and they have these magazines at the back of the seats that you can read. And there was an article or an interview with Sir Richard Branson. You know him from Virgin Atlantic, and he's now got Virgin Galactic, so he would like to make space travel accessible to everybody. So in the article, he wrote that he would like coal miners, janitors, and dustbin collectors to be able to travel into space as well. So he would like to democratize space travel. And this tool, Visual Analytics, is pretty much in the same realm of what he's trying to do. This is for everybody in the organization. It's not just for this elite group of data scientists or PhD statisticians that work in the dark offices in the back room. It's for everybody, so managers, even people in call centers might benefit from these tools. A couple of days ago at SAS, we got a kind of a news feed that at one university, the number of ad hoc queries decreased by between 40 and 60% because of visual analytics. Now the managers can go, and if they have a question, they don't have to submit an ad hoc query and wait for a couple of days to get the answers. They can actually drill down into the data and get the answers themselves, and the analysts can then be more productive. So let's start with a simple example. I'm going to focus on the interactive exploration. So obviously you can build dashboards as well, but I'm not going to impress you with my dashboard building skills. So let's have a little bit of fun exploring a couple of data sets. I'm also going to hopefully show you the analysis of unstructured data. You've heard unstructured data, so let me show you how that is done. So let's start with the basics. So I'm going to create an exploration, and I have a fictitious data set from a toy company. It's called the Inside Toy Company, and I'm just going to explore a little bit what is happening in my data. So this Insight Toy demo is the data set. And as soon as I load the data set into Visual Analytics, I get some frequency counts already of the number of customers I have in my data set. But let's just quickly see how big the data set is. So let's look at the data source details. So it's about 3.5 million records, which is definitely not big data. But remember, I'm running everything on my laptop. It's just the risk is too high to try and do something remotely because you don't know what the load on the servers and so on is going to be. So that's my data set. I have some categorical variables, and I have some measures. So let's say I'm not sure what to do with this data set. So let's select a couple of variables. So let's select quite a number of variables. And let's just drag it over to our visualization area and see what we get. So I'm using the automatic charting functionality of the tool. And there we go. So it gives me a correlation matrix of the variables. So I can see whether there's a high or low correlation between certain variables. So the dark colors is just absolute value of your correlation coefficient. So in this case, it's 0.86, and it is between two variables. Let's see, product cost of sale and product material cost. So you might think there's a large correlation. So let's pick one of these cells, and let's say I'm a manager now at a company. So I see this, but I did Stats 101 kind of 30 years ago, so I'm not so sure exactly what a correlation is anymore. So first thing I can do is I have this eye kind of icon at the bottom, and it will give me a little bit more information on exactly what a correlation is. So what does this mean? Correlation is the measure of association between two variables. The strength of the relationship is described as a value between -1 and 1 and so on. So, okay, now I remember what the correlation is. So, but I would really like to see the underlying relationship between these two variables. So let's pick one of these cells and double click on that. And immediately I see a scatter plot, and in this case I see a heat map because I've got too many data points. And you all know if you have 10 million or 100 million data points, if you try and plot it in a scatter plot, you get this big black blob. You can't see any detail. So here it's just basically my two axes have been binned. And there's a linear trend line being fitted. So this is where the real power comes in of the visualization. Is not just doing the visualization, but then adding the high power analytics on top of this. So here I have a trend line, and it looks like a linear trend, but let's change the fit line. So let's go to fit line, and let's say best fit. And there it looks slightly different. So now I have my high power analytics on top of my visualization. And this is really where it goes. And this is then called an analytical visualization. So let's move to a different data set. So this is basically the basics. At the top, I have different types of visualizations represented by these icons. And I'm going to use different data sets. Hopefully now you believe me that this will really work on large data sets, because it was pretty fast on my laptop on a couple of million records. So let's move to a slightly smaller data set, because there are some interesting things that I can show with this data set. And because we're also in the kind of talking about health, there's some health things that's kind of interesting. So let's move to a second data set. So some of you might have seen this video by Professor Hans Rosling, where he animated life expectancy, income, and population over 200 years for more than 200 countries. So I took a selection of his data, and I'm going to show you at least 4 ways of visualizing your data on this data set. So it's a small data set, but that doesn't really matter. And let's just select a new data set. So this data set is called Life Income Population. And I'm going to show you some interesting features. So let's say I don't know how to visualize my data. I have 10 countries. I have 63 years of data. I have income, life expectancy, and population numbers. So let's select everything and give it to the tool and see what it produces. Okay, so maybe this is not the best visualization produced ever. And the reason for that is I have various different scales. I have population in millions and billions. And then I have life expectancy less than 100 years. And I have income 0 to about $45,000. But at least I can see my countries, Germany, France, China, and so on. And I can see that I have kind of time series data, and I can hover over some points and see more details. Okay, so let's try and do this a little bit better to see if we can understand our data. For that, I'm going to add a new visualization, and I'm just going to dock this one at the bottom so that we have more space available. Okay, so I have 63 years of data. So let's drag the 63 years of data to my visualization, and I would like to so let's do this another way. So I would like to do a line chart. So this time I'm going to tell it what I want. I'm not going to use the automatic visualization tool. So I have years. That is going to be my category variable. And my measure that I'm going to show, let's look at life expectancy. So in this case, I just see frequency. So I have 10 countries, and therefore I see 10. So this is kind of, okay, life expectancy 750, that's a bit odd. Because now I have life expectancy for 10 countries, and maybe I would like to see it by country. So not the sum of the life expectancies by country. So let's add a filter by country. Just select country and drag the variable over, and let's look at the life expectancy in the US. So let's select the United States, and there we see the life expectancy in the United States. It was around 68 years in 1950, and now it is around 78 years in 2012. Okay, so you can say, okay, many other tools can do that, so what is novel about this? So remember my idea of adding high-powered analytics on top of this. Let's do a bit of forecasting. So let's see where the life expectancy of the US is going. So I can right-click and select Show Forecast, and immediately I see forecast for a couple of, let's just drag that, for the next 6 years. So it seems like the life expectancy in the US, just given this time series data, is still going up, but as we know, there are some other factors and things. So maybe I should need to throw in some other factors as well to be able to do this. We can also then say, let's change the time period, maybe to 12 years, and let's see where the life expectancy in the US is going. So you might be a manager and you might not remember what these kind of gray bars mean. For that, you have the little I, and it tells you the forecast shows the predicted values of the measures based on historical values. The bands account for forecast represent a 95% confidence interval of the forecast. Okay, so now I throw in my high-power analytics on top of my visualization. So I've already have 2 visualizations. So let's add another one. And let's do an animated bubble plot to get closer to what Professor Hans Rosling did. So I'm going to add a new visualization and just dock this one at the bottom, and I'm going to do an animated bubble plot. So on the x-axis, let's do income. On the y-axis, let's do life expectancy. And let's use population as the bubble size. So immediately, I see all my data, but that's not really what I would like to see, I would like to break this down by country. So have a grouping variable, and that's country. And I only have United States, and the reason for that is I have a filter. So let's show all the data. So immediately I have all my 10 countries, but now the interesting thing is let's animate this by year. So let's select year, and that is our animation. And now we can see what happened, or what happened to life expectancy, income, and population during the last 60 years. So let's play this, and there are two trends that jump out. So let's see if you can kind of identify these two trends that jump out at me, and then I'll give you my version of these two trends. So there we go. So around 1960, 70, everything's going well. Income is improving. Life expectancy is going up in most countries. But then this country is completely going south. And we have the bubbles getting bigger as the population improves or gets bigger. So in China, 1.35 billion, that seems about correct, in 2012. If we look at United States, the income is about just less than $43,000. Life expectancy about 78 years. And here we have Japan with the highest life expectancy of about 83 years. And we have India with the lowest income per person of about $3,200. So the two trends that jump out at me is first you have to look at China and then South Africa. So if I play it again, so China, it seems like life expectancy is going up and then it dropped. And that was because of the Cultural Revolution. And some sources say that up to 45 million people died of famine in China. The second part that is interesting is this bubble going down. And this is South Africa. And as you can see in 2012, the life expectancy is still below 60 years. And it was around 50 years a couple of years before that, and the reason for that is AIDS. So the country is only now realizing or getting to understand the effects of AIDS and how to live with that. So managers really like this, but let's say you are kind of the newer generation. Kind of animated bubble plots are like so last century. You want a text, a word cloud. So let's do a word cloud on exactly the same thing and see how it looks. So I'm going to add a new visualization, and I'm going to do a word cloud. So we saw some really nice examples of word clouds this morning. Let's use, I'm going to show you an example of text analytics using a text documents, but let's first use a category value. So let's use the words of the country names. So they are my countries. And let's show life expectancy by size. And then income is the color. So immediately you can see that United States, because it's pretty big, and the United Kingdom, and then Japan, they have kind of large expectancy is much higher than some of the other countries, and you can also see the color. India and China are lacking behind, while the United States and so on are in front. So let me get all my visualizations up here. So in about 10 minutes, I showed you 4 ways of visualizing your data. So there's not one that's absolutely correct, but for different groups, you might need to do it differently, and I showed you 4 possibilities of doing that. So let's go back to the word cloud. So you might say, okay, this is kind of easy example. Let's go to a real example using a word cloud on a real document collection. So for that, I have a new data set. And this is a subrogation data set. So this is an insurance data set with just more than 3,000 documents. And these documents are unstructured documents. Those are adjuster notes. So you can always, if you still want to look at the table, force the system to give you a table. So let's look at the adjuster notes. So these are my adjuster notes or my unstructured data that I'm going to analyze. So my first adjuster note is for claim strained neck trying to catch falling product. The second adjuster note is fingers caught in machine. Okay, so this is completely unstructured. So how do I analyze this data? So obviously you can do some text mining, and SAS has a text mining product for doing that. But what is really neat about visual analytics is that you can do basically very simple text mining inside the tool. So what I need to do is just indicate to the system that my adjuster notes, that is my document collection. And I also have to indicate a unique key identifier to be able to do this. So I'm going to minimize that, and I'm going to tell the system that I would like to do text mining or create a word cloud based on this document collection. So in this case, I'm going to do really text analytics, and my adjuster notes is my document collection. So it takes a couple of seconds, and here is now a real word cloud. So I can see at the top, I have a couple of topics being identified within my document collection. So I have one topic with words identifying this topic, so important words. And also the size of the word gives an indication of the importance of the word in characterizing that topic. So I have low, back, lift, and pain, and these pluses just means that it's stemmed words. It might be synonyms and past tense and present tense and so on that was used to create this term. So I have one topic around low, back, lift, and pain, so maybe injuries, people picking up heavy stuff, and so on. Then I have two other topics that were generated. This one is vehicle accident involve motor, so maybe vehicle accidents. And then I can see the most important term in identifying this topic was vehicle and accident and involve. And then the last topic that was identified was finger, door, hand, cut. Maybe some person catching his or her finger in a machine or on the door, or as you can see, machine and amputation, middle finger, and so on. So the previous speakers and the panel talked about unstructured data, and we discussed doctor's notes, insurance notes, and so on. So this is a kind of pretty easy way to get a handle on that unstructured data to try and analyze it. Now, a couple of days ago, it might even have been a couple of weeks, we had this political, what was it called, where everybody got together and they kind of asked all the Republican candidates some questions. What was it called? The debate. Thank you, the debate. So somebody at SAS, and there are some really clever people at SAS, took a transcript of this debate and they analyzed it using visual analytics. So unfortunately, I haven't got the latest details of that, but that might be an interesting exercise. So what this leads to is something called sentiment analysis. So unfortunately, I don't have the latest version of SAS Visual Analytics on my computer, but in the latest version, there's just a little box, a select box like you have over here, and it says sentiment analysis. Then you can do sentiment analysis. So you could, for instance, say, okay, analyze this debate, whether people thought it was positive or negative, or you could think of an example of Apple maybe releasing their Apple Watch. You could get some tweets from Twitter in a specific time period, and then analyze it to try and gauge whether the sentiment is positive or negative. So as soon as you click that or hit that little button, sentiment analysis is being done for you on this unstructured data. And then it's very undramatic to click that little box over there, but then what you get is you get 3 little emojicons. So you get a kind of very sorry face, kind of a neutral face, and a smiley face, red, yellow, and green. and you'll see exactly which text documents are associated with the negative comments, the positive sentiments, and the neutral sentiments. So this gives you another way of analyzing your unstructured data using sentiment analysis, which if I was out there and I had to motivate why to buy this tool, I think that would be my top motivation for getting visual analytics is doing sentiment analysis on structured data. But maybe I'm short-selling the tool now by saying that. So this is usually a feature of visual analytics that is not being demonstrated a lot because you really have to set it up correctly. We have something here called a stop list. So that's kind of a list of terms that we do not want to see in our analysis. For instance, is and the and are and punctuation and so on is taken out, and those are words that are in my stop list that I do not show. So I have a last example, and now I must think what my last example is. Just a second. So let's look at the data sources. Right, so one of the other features of visual analytics that you probably haven't seen and is also connected to social media is network analysis. So in network analysis, you have people connected and liking other people, and you have influential people and so on. And so analyzing these social structures is becoming like a science on its own. And I'd just like to show you a small little example of a network analysis. So in North Carolina, we have some training centers at SAS. We have one in Cary, then one in Asheville, one in, I think, Greensboro, and one in Charlotte, if I'm correct. So we can see where people come from in the state to take our training classes. So I can think of a scenario at a university where this could be very useful for a university, looking at all the courses and then looking at your feeding sources for where the students come from and so on. So this could be a kind of a really, really useful tool. So let me see if I can end off with that example. So just a very, very small data set, but also a couple of weeks ago, we got a kind of information from our boss, Dr. Jim Goodnight, that you shouldn't just sell visual analytics to big corporations for tens of thousands of dollars. You can also sell it for reasonably sized data sets and even small data sets. And as you can see, it really works well, even on small data sets as well. So maybe there's a commission thing involved in this. So if you sell like to a big company for $1 million, you get big commission. But if you sell the tool for $10,000, how much commission do you get? So that's maybe a reason why the salespeople were kind of focusing on the big companies, and they were not really climbing or getting into the smaller market for visual analytics. So let's open up our data set. So small data set again, and always you can look at your data set, you can look at the table, but just be careful. This tool was designed for big data, so if you have 1 billion records and a couple of thousand variables, you do not really want to look at the table, maybe a very selected part of a couple of variables out of the data set. So I'm going to do a network diagram. So let's see if I can get this to work. So another feature of the tool is that you can very easily build hierarchies, and you can do geo-mapping. So previously, geo-mapping was kind of an issue. You have to get your data out of one system and get it into another system, and then you would be able to do your geo-mapping. And also building hierarchies, you had to build all these OLAP cubes, and you had to define in advance how deep you would like to drill down in your data. So now you can do this all on the fly in SAS Visual Analytics. So I have two zip code variables, training zip and NC zip. So this is the training center, and NC zip is the zip code of the customers coming to our training. So let's create a hierarchy using those two zip codes. But first of all, I'm going to designate this as geography variables because the tool knows about zip codes and states and so on. So let's make a geography variable out of NC zip and another geography variable out of training zip. Now I'm going to build a hierarchy on these two geography variables. So let's build a new hierarchy, and I just have to now tell the system the order of my hierarchy. So the training zip is the top level of my hierarchy, and NZ zip is the second level of my hierarchy, and there I'm done. So let's do the network diagram, and the only thing I have to do is drag my hierarchy onto my workspace, and there I see a network diagram of my training centers and all the customers coming to my training center. But maybe I would like to add a filter so I can be selective in the cities I use. So let's add a filter on training zip. So here we have the 4 training centers in the United States, in North Carolina. And maybe there's some interesting patterns in this network diagram. So one I found was that some customers sometimes go to one training center and sometimes go to a different training center. So what might be the reason for that? So let me just show you. So I'm going to select only 2 of the training centers. And here I can see one customer in this zip code going to 2 different training centers, and the other customers basically all going to one training center. But wouldn't it be really nice if I can show this on a map? Because the system knows about zip codes and geo-mapping, here I can see a map of Asheville, that's our one training center, and the other training center is Winston-Salem, and I think I can drill down. So a person from Statesville went for some training to the one training center, and the other time he or she went to the other training center. So I showed you here how to do geo-mapping and also how to build a hierarchy, and you can build a hierarchy as many levels deep as you would like. You can then also drill down on the hierarchy. So for instance, I can double click on my training zip, and if I am in the right, I can drill down one level, and as you can see, I drill down on that level, and if I had another hierarchy, I can pick one of these and drill down maybe the companies in that zip code that attended our training courses, and if I would like to go back, I can zoom back to the top level of my hierarchy, and let's just show everything we have on this map. So there's a map of North Carolina with some of our training courses and where our customers came from. So that's about what I have time for. So hopefully this gave you a kind of a brief view of what visual analytics can do. So remember, this is a tool designed for big data. You should get pretty similar performance even if you have a really, really large data set, obviously with the right high performance computer in the background. So maybe one question? I can't believe it was that good. So no questions. Okay, thanks very much. Let's go and see how big the prawns are.
That's the end of our formal program. I would like to thank all of you for coming. I would like to thank all of our speakers who I hope you all agree with me, did an outstanding job discussing business analytics, the importance of business analytics, the applications of business analytics. For those of you that are students, in the audience, I hope that this was encouraging in terms of the opportunities that are available in business analytics. As director of our business analytics program, I would be remiss if I did not point out our programs, as well as many of the other programs in the College of Business. And we have information in one of our brochures in front of you, as well as a table out front talking about a number of different programs in the College of Business. I'd like to thank our sponsors once again, SAS for providing excellent speakers, to the Monte Huja College of Business, and to our corporate sponsors, Progressive and Key Bank. I encourage all of you to stay. We have some hors d'oeuvres for lunch, and we hope that you will stay and socialize and sort of help with building of a analytics community. And with that, I will end our program, and once again, thank you for coming.